Hello, grade 11 Mindsetters. It is your chance now. Yes, we are live on Learn Extra Live. My name is Abram, and I'm not alone. I'm with Dina. How are you, Dina?
Hello, Abram, and hello, everybody. It's good to be with you this afternoon.
Oh, yes, I so missed being with you, on Mondays.
Missed being
But
here
it's good
too.
to
Missed you
learn
too.
to learn again on mathematics because I've been doing other shows. But for today, what are we doing?
Well, we on the grade 11 show, so we're going to be looking at trig equations, and we'll take the whole show to answer some trig equations.
All right, looking forward for that. Go take your position.
See you now.
Right, Mindsetters, I have three things that I need to tell you. One is that this show is proudly sponsored by Macmillan. Yes, and you can get the notes for free on our website, which is learnextra.co.za/live. That's just how it is. Simple. I also posted the first link on our Facebook page. 2 reminds me of our Facebook page. You can go over Facebook, interact with us, ask us questions, and let's help one another as Team Mindset. Our Facebook link is facebook.com/learn extra. And still on that Facebook page, you can predict and let us know when do you think we're going to hit 41,000 likes. Currently, we're at 40,529, but you can tell us, have a guess, and you could win this awesome t-shirt. Yes, it's beautiful, it's awesome, and it could be yours. Lastly, you can tweet us, follow us on Twitter at Learn Extra. But for now, let's learn more, Learn Extra, and become more. Dina, take it away.
Thanks, Abraham. Yes, grade 11th, it's trig again, and this time around we're really just going to focus on solving some trig equations. This year they're going to be pretty basic, but we are going to build onto grade 12, and so next year we'll introduce a little bit more of detail, so we do really need to know how to solve those equations because they get a lot more complicated as time goes on. Right, so the title of today's lesson, trig equations. What are we going to do during the lesson? In this lesson, we're going to define the concept. There's a word that we use or a phrase that we use, general solution. What is that? Which is used when solving trig equations. And we're also going to solve very simple trig equations or trig equations that you need to be able to solve at grade 11 level. The first one we're going to look at is determining the general solution for the trig equation of the form sine theta equals m. So if we have sine theta equals m, what is, as I said earlier, what is this general solution? Okay, now, sometimes we try not to find things at the beginning because the concept actually develops with time. So I'm going to do a little bit of work, give you an example, and then at the end we're going to come together and say, okay, well, now I understand what that general solution is. Okay, so in front of me I've got the graph of y equals sine x. So we've got y equals sine, just checking it's x, okay, over a domain of 720. So we've got the sine function starting at 0. It's got a maximum at 90, then goes through 180, minimum, goes through 360, etc. And the equation that we're going to look at is the one that's defined by, so an example of this would be if sine x equals a half. So when you use your calculator with a trig ratio, you often have the angle, and you would take sine of the angle in order to get the ratio. With a trig equation, what we're saying is we are going to be given the ratio. We need to work out for which angle will sine have that ratio. So we're actually working on the inverse when we are trying to find the angle. Okay. Now, this line over here denotes the half value. Okay. And if we place that onto our calculator, if we take the calculator and say, what is the angle if we have the ratio of a half? What the calculator does is it's been programmed to give us one angle, and that is 30 degrees. However, if we look at our graph, we see that we get 30 degrees. That's the value that the calculator gives us. But notice that there's another angle that gives me a half. There is another angle that gives me a half. There is another angle that gives me a half. There are more angles to the left of 0 that give me a half. And you've got to understand that this function, I can carry on plotting it. There's oscillations between 1 and -1 that carry on to infinity. So these green angles are not given by the calculator. Only one angle is given by the calculator. So the word general solution asks us to find a formula that would actually be able to give us all the green angles, because there's not only one angle that gives us sine a half is, or sine of x equals a half. We've got one angle is 30 degrees. What is another angle that we could use to give us the ratio of a half? Well, if we go back to our Cartesian plane work, we should be able to think through this, is that if that's 30 degrees, then I could have an angle of 150 that could also give me the ratio of a half. And then if you work with your Cartesian plane, in recognizing that if you go 30 but you go 360, you've got another angle. And if you had to take 120 and rotate through 360, you'd get another angle. And you could rotate in the opposite direction to get some coterminal angles. So already we know that we're going to get these cycles of, or these period of 360 degrees, which is going to give us another and another angle. So that word general solution is the formula that will actually give us the blue angle, the orange angle, the white angle, and any other derivatives from there. Okay, so how can we start, or what could we look at in terms of getting our angle or angles from the formula that I've described to you? Well, the first one is that the calculator has given us this angle of 30 degrees. And we're going to use something very powerful, and that is that we know that the sine function is periodic, which means that after every 360 degrees, the same thing is happening. So if I have to travel from there and I go 360 degrees all the way to this value here, I've traveled 360 degrees. If I go to the minimum, to the maximum, and then over here, I've traveled 360 degrees. And if I keep going, I've traveled 360 degrees. So I really do know how to get these green angles. They are simple. They are simply values that I can get by using the period or the periodicity of the function. So the green angles, I could say, if I had sine x equals a half, I could say that x is, the calculator gave me my first value of 30 degrees, and then I'm adding 360, or I'm subtracting 360, so I could then add on multiples of 360 degrees. So if I add one 360, I'm going to get to this value of 390. If I minus 360, I'm going to get to this value, and if I minus another 360, I'm going to get to that. So one angle is my calculator angle, and this term here is just telling me that I'm going to add on the period in order to get my infinite number of values. So here, k would have to be an integer. Notice that k is not a fraction. I'm not going to say 30 plus 180 degrees. So I'm really going to use the function's period where k is an integer. Right, now let's see what's happening with the other angles. What about this one? Okay, how do we get this angle over here? How do we get this angle over here? And how do we get this angle over there? So how do we get the blues? So if sine x equals a half, then what is x in terms of the angle that I'm getting here? Well, we know that in the first quadrant, x was 30 degrees, but this angle after 1 is all values between 90 and 180, which is my second quadrant angle. And in the second quadrant, we would get 180 minus 30 degrees. So this second angle is just 180 minus 30 degrees. And again, can you see if I go decrease, I start repeating myself there. So this one here would be the sum, or left and right the sum of 360 degrees. So this would be plus k 360 degrees. Remember, this k has got to be an integer. It cannot be a fraction. So, to recap, we took our calculator and we found out what is the angle that has been programmed to give us a half, and we found out that it was 30 degrees. From that one angle, we are able to get three things. One, we're able to get the general solution to determine all the other green possibilities. We've been able to determine what the second angle is, because once we had the green ones in the period, we didn't have these blue ones. So these blue ones came from knowing that in the second quadrant, sine is also positive. Notice that the third quadrant and the fourth quadrant, the ratios are negative. And so we were able to get the blue angle, which is 180 minus 30. And then we were able to find the general solution for the blue ones. So we always are working with four things. One angle that the calculator has been programmed to give us. Two, determine the general solution. Three, find the second angle from the diagram. And then fourthly, the general solution for the second angle. So in order to get all my green and blue angles, I must have two sets of formulae. And that is what's known as the general solution. General because it generalizes for an infinite number of angles. The formula does not give us one case, it gives us many cases. So if k was naught, for example, x would be 30, which was the angle that the calculator gave me. And if k was 0 here, x would be 150, which was the second quadrant angle. So depending on which k value you use, you'll then be able to go and find definite or finite values that would be in that domain. Okay, so the question is now, well, what happens if, let's say, sine was equal to negative a half? What would anything change, do you think? Okay, so if we had our sine x is equal to negative a half, what would change, if anything? Well, let's first of all see what the calculator has been programmed to give us. So if sine was equal to negative, then the only thing that changes would be this ratio over here. It becomes negative. And everything else stays the same. And by the way, in order to find the angle, it's the function that's in yellow or the function just beneath the ratio button, because the inverse of getting the ratio would be to get the angle, so the inverse is found underneath that. So what do you think the calculator has been programmed? It could be using any of these angles here that give us that a half, so it could be using any of those. What do you think the calculator has been programmed to do? Well, let's see how it's been programmed. Okay, it's giving us negative 30. Where is negative 30? That is in the fourth quadrant. So negative 30 would be about here. So that would be that angle over here. That would be negative 30. Okay, so that's great. So our first solution would then be negative 30. What would the general solution be? Well, the general solution would be the formula that would give us 360 degrees later, 360 degrees later, back this way, 360 degrees later, and back this way, 360 degrees later would be somewhere there. Okay, but can you see that there's some values that are missing? So this angle over here is missing, as well as that one, this one, and this one. Okay, so the orange ones we could write down very easily. If sine x is equal to negative a half, then the calculator gave us negative 30. The period of the sine graph is over 360 degrees. So there's my general solution. Okay, calculator angle, period. But what about the purple angles? How are we going to find that purple angle? Well, this purple angle over here is at 210 degrees. And can you see that it's 180 plus 30 degrees? Now, if the formula has given us above 180 minus 30, look what happens in this case, as minus a half, would be 180 degrees minus what the calculator gave us, plus the period. So there's our general solution if it's negative. So in other words, we could actually conclude that it's always the calculator angle and the period, and the second solution is always 180 minus the calculator angle plus the period. And that would be the general solution for the sine graph.
Right, well said on that one. I have a quick question that I'd like you to answer, but should I give you after the break?
Yes, that would be
All
great.
right, we'll do that. Mindsetters, stay on the loop because after the break, we've got something big and exciting that you don't want to miss. It is a huge thing we've been telling you about from last week, but now it's happening this week. Stay tuned. Welcome back, grade 11s, and now it is that time that we've all been waiting for. As promised to you from last week, that today we're launching our big competition that is focused on a movie called After Earth, starring by Will Smith and Jaden Smith. It is an awesome movie, a science fiction, and trust me, you are going to enjoy it. But we've got this competition. All you need to do is to watch this trailer firstly, and then after the trailer, I'll be giving you a keyword. That keyword specifically for you as grade 11, it is different from all other keywords. It's just for you. After hearing this keyword, you will need to go to a link that I'll give you, and then you're going to type in that keyword. It's just going to be your entry to this competition. I'll tell you about the competition details right after the trailer. You must see this, guys. See you after this.
In the field, you are emotionally unpredictable. You confuse courage with recklessness. I'm not advancing you.
You have a son that you do not know. He's reaching for you, and he does not need a commanding officer. He needs a father. Now go make some good memories together.
Crash landed. 2 confirmed survivors. Do you know where we are?
No, sir.
This is Earth. There's an emergency beacon in the tail section of our ship, approximately 100 kilometers from here. We need to retrieve that beacon.
Or we're going to die.
Everything on this planet has evolved to kill humans. Together, we will survive.
I hear something.
It has found you. We must abort this mission.
You wouldn't give any other ranger that order!
You are not a ranger. You are my son. Remember, danger is very real. But fear is a choice. If we are going to survive this, we fight.
Welcome back, guys. Now, after seeing that awesome trailer, trust me, that is a reason enough for you to go watch out this movie. If you would like to win double tickets for you and your friend to go watch out this movie coming soon on our cinemas on the 7th of June, all you need to do is type in this keyword on the address that I'm going to give you. The keyword for this show, grade 11, it is humanity. Humanity. I'm going to repeat it maybe 4 times, but it is humanity. All you need to do is to go over this link. Jump now. It is learnextra.co.za/After Earth. learnextra.co.za/After Earth. The keyword is simple. Dina, you would agree with me. Humanity.
Very simple.
Humanity, guys. That's your entry to this competition. The competition is closing at 12 midnight today, so you've got all the time that you need. But unfortunately, it is only open to people that are in South Africa only. But other mindsetters that are from other countries, Nigeria, Kenya, guys, will have something for you some other time. But for now, let's get back to Trig.
Here we are, grade 11s, yes, back to Trig, and some of you are posting questions on the page, asking about the periodicity of cos and tan. Well, you almost got ahead of me. I've got that as the next slide, so we're going to look at the cos and tan functions. And just to echo what Abraham was said, remember your keyword is humanity, so get posting those answers so that you can win some prizes. Right, and so cos function, here we go. I'm going to again take an example of a ratio that we're going to use, just something very familiar that we're familiar with, if cos theta equals a half. And in this case, our x-axis is x. So let's just be mathematically correct here, and let's just make this cos x equals a half. Okay, so if cos x was equal to a half, then this line is my half line. And so I'm able to already tell that I'm getting some angles where it's crossing with the curve. There they all are. I can see all those intersections. And I'm really interested to see if anything changes between the cos and sine. Let's go to the function. And in this one here, let's delete that, and let's put in our function cos. There we go. And we'll start off with the, okay, it's not really cooperating. So we're going to do that, and we're going to take a half. And what are we going to have? We're going to have 60 degrees. So where is that? The cos function is 60 degrees over here. So I'm going to color that in. There's my 60 degrees. Okay. And then I've got 360 degrees later. When it's decreasing, I'm getting another value. 360 degrees later would be over here. 360 degrees this way, and another one. So I've got all these yellow values. They are all found from my 60 degrees. I don't know that you can read that so clearly, so let's just make this a little bit clearer. That's 60 degrees. Right, so remember what we did with the sine? We said the calculator gives us 60 degrees, and then our cos function is also periodic over 360 degrees. So we're going to get 360 degrees later one solution, or the second one 720 degrees later, or one this side would be minus 360 and another one would be minus 2. So they are cycles. K is just a cycle of 360. So to answer that mindset, we pose the question about the periodicity of cos. Yes, cos is also periodic over 360 degrees. So we will always say plus k 360 degrees. Now the ones that we haven't filled in are these ones over here, the blue ones. Those are missing from my yellow formulae. So how are we going to get those? Well, the cos function is quite a friendly function. It's not like the sine that's got these values all over the place. The cos function, if I had to put a mirror over here, you would agree that that's my y-axis. So if I flip this graph this way about the y-axis, I would get all these answers this side. So this blue angle is actually just the additive inverse of what's happening on the right-hand side. So this blue angle, because it's symmetrical, will be minus 60. So x is actually equal to minus 60. How amazing is that? That's pretty simple. So the calculator gave us 60. We filled in the period to get all the yellow ones, but then the blue ones are even easier because we can just flip it around the y-axis and get negative 60. But remember, we don't only get one answer. How many do we get? An infinite number by using the period. So the period captures, or it catches, every single possibility. So my general solution would be, let's just make this yellow, would be this. and it would have, or it would have this. And don't forget, somewhere in here you've got to say that k is just not an arbitrary variable. K is a fixed number. It's plus 1, I'm adding 360. Plus 2, I'm adding 720. Minus 360 or minus 720. So that's the periodicity of the cos function. Okay. And then we're going to also look at what happens with the tan function. As you notice, I've left the easiest for last because the sine had those two different formulae with 180 minus. The cos is simply the additive inverse of the angle that the calculator gives you, so we don't even have to think about that. And the tan, what happens with the tan function? Okay, so if we had, for example, tan theta equals 1. If tan theta was equal to 1, what is the period of a tan function? Period is 180 degrees. So whatever the period is for your normal graph, you're going to find that you use exactly the same period in equations. So graphs help you to solve an equation. So if that is 1, we're going to get our calculator. What does it say? So just delete that. And we've got function to find the angle is tan to the minus 1 of 1. What angle will it give you? Okay, it gives you 45 degrees. So we've got 45 degrees over here. That's my 45 degrees. But now, the function is periodic over 180, so my next value is going to be over here. And my next value is 180 degrees before that, and 180 degrees before that. Now look what's different from the two graphs we've done previously. We're getting all the solutions on a period of 180 degrees, but the beauty is that there are no missing angles. So the general solution for the tan is the given calculator angle plus its period. And we've captured every single solution. Isn't that amazing? So tan is really, really easy. What about a negative ratio? Let's have a look at an example of a negative ratio. Here's -1. What would happen then is, can you see it intersects here? So what has the calculator been programmed to do? So let's just clear that. Tan of -1 equals -45. So we've got, gives us this one, and that's the value that it's giving us, a -45. If we add on 180 degrees, we're going to get this one, add another 180 degrees, minus 180 degrees, minus. So again, if the ratio is negative, if tan theta is -1, then theta will be what the calculator gave you with the period. Okay, so this finds every single possible angle that you can get from negative infinity to positive infinity. Hence, it's called the general solution. Okay, now I want to go and do some examples just to look at some variations. What happens when the trig ratio hasn't been isolated? What happens when something's going on with the angle? And how we treat those in a very different way. But before that, I want to just go back to the cos function. I think this was our cos, yeah. And just go through with you what would happen if we had a negative ratio. Because the same procedure happens. You're going to draw in the negative ratio. And then we just want to see what the calculator would do. So if you have cos x equals -1/2, for example, what do you think the calculator is going to do for you? Well, let's test. What's it going to do? How's it been programmed? Remember, these things have been programmed to give us these values. So it was a -0.5. Okay. Look what it's doing. 120. What is 120 degrees? It's in the second quadrant. And that's where cos is negative. So it's been programmed to give us a second quadrant angle, which means we know that if it's the third quadrant, we're missing the third quadrant angle. Okay, so the calculator has given us 120 degrees. And we've got to add on the period. So this is what the calculator's given us. It's given us this value here. 120 degrees. Add on 360, minus 360, minus 360. Okay, so that's the one for this side. What about the other value? Let's work with this one. What about this value here? That's missing. What about this value here? That's missing. All these are missing. How are we going to get those? Well, this one, remember the cos function is symmetrical. So I had the green one, but if I fold the green one about here, I'm going to get negative 120. So my second formula will be the negative angle plus K360. So we don't have to think about quadrants. The formula itself will give us a quadrant, because the negative 120, when I add 360 degrees, I get 240, which is my third quadrant angle. So the formula will, by its nature, give you all the possibilities when it's negative. Okay, as promised, let's do some examples and see the various variations. Okay. Okay, so the question says, find the general solution for the equations and hence determine the x value in the given domain. Okay, doesn't matter what equation we're solving, we're always going to find the general solution before we work with any of the domains. So I'm going to leave out the first one because we've done enough of cos x. I want to look at B. I want to focus on what happens if you get 2 cos x is equal to negative 1, 456. Now notice I've solved 5 equations with you already, and I think you would have noticed that we gave you the equation in the form sine theta equals a ratio. So the ratio has to be isolated, otherwise a calculator cannot find your angle, because the calculator has only been programmed to find an angle when the ratio is by itself. So a note we've got to make to ourselves is that you need to isolate the ratio. So if the ratio has got a coefficient, I've got to say coefficient must be 1, because the calculator can only solve if the coefficient is 1. So I'm going to take that, I'm going to say 1, 456 divided by 2. Okay. Then my general solution I can now go and find. And what is my general solution? I'm going to take, firstly, I can see the ratio is negative. We've just looked at the cos function with a negative ratio, and we found that the calculator was programmed to give us an obtuse angle. It's very important that you predict what the calculator is going to give you, so that you can argue whether you're happy with that value or not. Maybe you've punched things incorrectly, and so maybe you don't totally agree with what's happening. So to go through the cos formulae, it will either give you an acute angle, or it will give you an obtuse angle. And then the 2 other formulae will be the additive inverse of those angles. Okay? So if the cos ratio is negative, I'm expecting it to be an obtuse angle. Otherwise, we have done something wrong. Okay, so we can go fetch our calculator, and we can say my ratio is to find the cos of, and I've got a fraction, and I've got a negative 1.456, and I've got that over 2. And I've got that ratio. And notice how I haven't divided anything. I'm just putting everything into the calculator, because if I want to check later, I can see, have I got a negative? Have I got the right digits? Am I dividing by the right value? And that's equal to. Remember we said we were expecting an obtuse angle. So it's 136,7. So that would be x from the calculator. X equals 136,7 degrees, and it says here correct 1 decimal place, so that's why I've used 1 decimal place. And remember, it's period. That's one answer. We get a multiple set of answers, and from here I don't really have to think about anything, because I can say straight away that my second set of solutions are going to come from the additive inverse plus K360. This only happens in cos, where it's the calculator angle and the additive inverse. Sine, we'll have to use a formula, 180 minus, and the tan, we don't have a second formula. So both sine and cos will always have 2, tan only has 1. Okay, so that's what happens. Now, when they say find find x in the given domain, we've now got to go back to this domain here and say, okay, I only want answers that fall within that range. So I want a solution set. That's what I call it. And the solution set would be, if k is 0, for example, then I would get x as 136,7, which is within the domain. I would get x equals negative 136,7. Okay? And if I then add plus 360 degrees, I would get 496. So that's too big. It's outside the 360 degrees. So if I minus 360 degrees from that, I get negative 223,3. And that would be okay. So x, if k was negative 1, then x would be negative 223,3 degrees. Okay? And if I then subtracted another 360 from that, I would get negative 583, which now you can see it's outside of that 360. So I keep adding on multiples until such time as it's not within the set. So I would actually get 3 values that affect that domain. I think it's time for us to take a break, Abraham.
Thank you, Dina. On that note, before we take that break, let me just check some of the comments that we have. We have Lance Kupeta saying, so far so good. So great work, Dina. And the last one is from Sovu saying, I'm in love with maths. Thanks to Macmillan for bringing this show for us. I love this. So thank you very much, Msovu, Makamu, Kamza. And one last question, guys. If you've entered for the competition, you only enter once. So you enter once. It's grade 11, you enter once because you've got one keyword, which is humanity. See you after the break. Welcome back, grade 11s. 2 exciting things that are happening on our Facebook page. One is that we're asking you to guess, when do you think we can hit 41,000 likes? Currently, we are at 40,000. So you can guess and win this awesome t-shirt. And another thing, it is competition details on how you can enter for the competition, what you need to know about the competition, because we are giving away two Lucky Mind Cities double tickets to go watch out this new upcoming movie, which is After Earth. But for now, I see that Dina has got something exciting, which should get you talking and get you chatting right now and learning at the same time. What do you have, Dina?
Thanks, Abraham. Yes, grade 11s, you're very lucky. You're getting some movie tickets, you're getting a new application to work on, so things are very technological back here. I'd like to tell you about how to use Curio so that you can do some mathematical assignments and get some feedback straight away on your assignments. So something very exciting. You will need to register, and then you can use the application like any others. So here's the process that you need to follow. If you'll go onto contacts on Mixit, then you're going to contact manually, and you're going to enter the ID curio.co.za. You're then going to enter your username and your cell phone number, and when that happens, you're going to be given a confirmation number via SMS. So a confirmation number will be sent to the phone by SMS for you to complete the registration process. You're now at the stage that you want to register, and so you now, with that number, are going to go to your general applications and open the Curio app. You're then going to use that confirmation number that you got on your SMS to register. So this confirmation number is only for registration of that application. Once you have been registered, you can now go and do some mathematics assignments. And you are going to enter another code in order to do the assignments. You are going to enter this code, M11, for the assignments. You are not going to enter the confirmation code for assignments. So the confirmation code is only for registration of yourself to Curio. You will need to enter M11 in order to do the maths assignments. If you enter the confirmation number to do assignments, you're not going to get through to us. So you need to enter that. There are 5 questions there that you need to complete. If you only complete one, you're not going to get feedback. So please complete all 5 so we can give you some feedback on that. So just quickly to recap, we've got, go to your contacts and Mixit, add add the curio.co.za manually. You then enter your username and your cell phone number. You will get a confirmation number. And remember what to do with this confirmation number so that you can register on the platform. So that number is only for the registration process. Once you've been registered, you can now go on to Curio and complete the 5 mathematics assignments with the code M11. Very easy, Mindsetters. It's maths grade 11, so that will be the code for your mathematics assignments. Get started on your assignments. Let's see how much feedback we can give you. Right, we're now back to the trig. Let us just go out of here.
Right, on that note, while we're still trying to get back, Mindsetters, the page is simple. Facebook.com/LearnExtra. We've got so many exciting things. Competition details are there where you can win an awesome movie ticket where you can go, you and your friend, or just highlight me and we'll go together. Or else, if you want to win this awesome t-shirt, you can also get details on how can you guess and win. That's how simple it is. When do you think we can hit 41,000? The time and the date. It's just so simple, Mindsetters. For today's notes, also, they are downloadable for free on learnextra.co.za/live. Dina, let's continue.
Right, back to the trig now, grade 11s, and we left off with where we had the coefficient of the trig function was 2, and we had to isolate the trig function to make the coefficient 1, otherwise the calculator cannot find the angle. So now I'd like to look at something a little bit different. What happens if the coefficient is next to the angle? How are we going to treat that? Well, in this case, as long as the coefficient of the trig ratio is 1, the calculator can find the angle. But the calculator is going to find the angle 2x. So this 2 does not move anywhere. It gets attached to that variable that you are going to find the calculator angle, or 2x is equal to the additive inverse. So I'm just using too much space. I need to just space myself out a little bit here. So we're going to say 2x is equal to the general solution, or 2x is equal to the general solution. So when the coefficient of the trig ratio is 1, we can automatically go back and find out the angle that gives us 0.123. And that would be 82,9. So we've got 2x is equal to 82,9. Calculator angle. At the same time, I've got to fill in the period. Or 2x equals, remember the cos function is symmetrical about the y-axis, so I need the angle that's symmetrical to 82, which is negative 82. I don't have to think about anything with a cos function. And I just fill in its period. Now that I've got 2x by itself, I can now solve for x. So I divide by 2 on the left, I divide by 2 on the right, so x equals to 41,45, so 41,5 degrees, plus 2 terms, I'm dividing by 2, so the period has now been affected as well. For those of you who've sketched the function cos 2x, will know that the 2 affects the period. But when you're solving for the equation, we don't have to think about how the period has been affected. The way that we are performing the algebra will bring out the new period. I don't have to go and write what the new period is, which is really nice. The algebra sorts that out for us. Okay? Or on this side, I'm going to divide by 2. I'm going to divide by 2. So x equals negative 41,5 degrees plus k180. And remember grade 11, somewhere over here, I've got to say where k is an element that looks like a z, where k is an element of the integers. Otherwise, that's not true. Okay, so back to this one. Remember, when anything is happening to the angle, it stays there. And you will write your general solution in terms of the angle that you were working with. So it's 2x equals, and remember there's always 2 parts to it. Okay, so we dealt with what happens with the coefficient. We get rid of that. The angle, it stays. Now, let's go on to another slide. Okay, so this example, 2 cos x equals 0,87, we would have divided it by 2. The sine, what would happen there? Let's see if we can just extract this one there. Sine 2a is equal to 0,87. That's the equation, equals 0,87. And we don't really deal with a, so I'm just going to change that and make it an alpha. Let's make this an alpha. Angles come in Greek letters for some other reason. Okay, so I'm going to make that alpha. Okay. Can you see the ratio is by itself, so we don't have to isolate the ratio? And what is the formula for sine? The sine formula is 2 alpha equals my calculator angle plus its period. Or, how do we get the second? Oh, we haven't done this in a long time. How do we get the second value? It's always the 180 degrees minus the calculator angle plus K360. Grade 11, some of you around the country may use the reference angle. I use it as a calculator angle because that's where we find it. Doesn't matter, as long as you're referring to that one thing that is going to help you to find the general solution. So, let's go to our calculator. We're ready to find the ratio that gives us 0,87. So we've got an angle of 60,5. 60,5. So 2 alpha is equal to 60, just check that again, 60,5, 60,5 plus K360. And now we can solve for alpha. So now you would divide by 2 and divide by 2 on the side. So alpha equals 30,3 plus K180. And on the other side, we would have 2 alpha is equal to whatever that is, minus 180. Remember, working with the positive side there, so it would be 119,5. Let's just get that. So it would be 119,5 plus K360. We would now divide by 2 to just get to alpha. Divide by 2, divide by 2. So alpha would be 5,9,8 plus K 180. And somewhere we must write what's the nature of K, where K is an integer. So the general solution for sine is the calculator angle plus the period, or the second set of values is 180 minus the calculator angle plus K 360. Okay, so that's if the angle has got a coefficient. Okay, and then what about tan? This function over here, are we ready to solve? Yes, we are. We just have this complex angle in here, but that's fine. We're not going to worry about that. We want to go and find where is tan equal to negative 624. So let's see. Where is tan equal to negative 624? Where is it equal to that? At negative 89,9 degrees. Okay, so we would actually need to write down that it was the tan of, what did we have in the bracket? Theta over 2 plus 10. Theta over 2 plus 10 equals negative 624. Remember, the tan function is very friendly. It only needs one formula. So the angle theta over 2 plus 10 degrees will equal to negative 89, comma, do you remember what that was? 9. Negative 89,9 And what is the period of a tan function? Excellent, 180 degrees. And one formula will give us all the tan solutions. We don't need a second formula. Tan is really, really friendly. So with that, I can now solve for theta, because theta over 2, I'm going to minus 10 this side, I'm going to minus 10 that side. So that's minus 99,9 plus k 180. That's a variable, that's a number, so I'm only adding the numbers on numbers. And then what do I do to solve for theta? I multiply both sides by 2. So it's 2 times my negative 99,9 plus k 180. And that gives us, if we just take on the calculator, that minus 10. And we multiply it by 2. We get negative 199.8. Negative 199,8. And 2 times that is k 360. And that would be the general solution of theta, of that tan function. Thank you, everybody. Over to Abram.
Thank you very much, Dina. On that note, Mindsetters, here's your keyword for the last time if you were watching and you've been hearing a lot about this competition that we're running, which is all about the new movie that is coming after Earth. The keyword for the last time is humanity for you, grade 11s. A big thank you to all the Mindsetters that are helping one another on our page, just like Silo Arthur. A big ups and thumbs up to you, Mindsetter. But also, thank you to our proud sponsor, which is Macmillan, for making it possible for us to get the notes that we are having on our website and for you to learn more, learn extra, and become more. Thank you very much. See you some other time.